Okay, finding zeros of polynomial functions. I'm sure we've done some of this before. Right, just a regular quadratic. Okay, this will factor into x plus 2, x minus 4. So the solutions are x equals negative 2 and x equals positive 4, which are the zeros. Okay, in other words, the x-intercepts as well. So here we go, at negative 2 and positive 4. So that's where it's going to cross the x-axis. Minus 8 there, so negative 8 when x is 0. Y-intercept is negative 8. There it is down here. The minimum, now just remember, if you want to do continuation, do a nice smooth curve, you want to know where the minimum is for a quadratic. That's at negative b over 2a. If I do negative b over 2a, I'll get x equals 1. There it is. And if I put x equals 1 back into the equation, 1 take away 2 take away 8 is negative 9. Okay, so y would be negative 9 for the minimum when x is 1. X is 1, y is negative 9 would be at the minimum. Okay, so that's just you looking at the zeros and graphing a quadratic. How about a cubic? Again, if we factor this into this, then the solutions, the zeros, the x-intercepts, we've got negative 3, negative 1 and positive 2. So negative 3, negative 1 and positive 2. Again, it's a positive x cubed. It will rise to the right and fall to the left. Okay. Where these max and minimum, we don't know right now. Okay. But you can put other points in between. You can plot when x is 1, what is y. You know, you don't have to just plot the x-intercepts and assume it rises to the right and falls to the left. You can see what happens in between by adding a few more points in. Okay, so that's the cubic one. Now, supposing here, something that doesn't factor. Okay, what they're doing here is they're testing to see if 2 and negative 5 are zeros. Where before we factored, again, we found here the zeros were negative 3, negative 1, or 2, okay, by factoring. Here we're just saying, is 2 a 0? Okay, well what happens is, if we put it straight into the equation, okay, what's 2 cubed? 8 plus 2 squared, again I'm just putting 2 in here, take away 7, it's not going to give us 0, okay, it'll give us that, negative 7. If I put negative 5 directly into the equation, apparently it comes out to be 0, okay, try it yourself, put negative 5 into the equation, which means negative 5 is a 0 of this function, okay. Now if negative 5 is 0, then this must be a factor, okay, that must be one of the factors of this. There you go, because if I put negative 5 in there, I'll get a 0. Okay, so that's just you throwing some numbers straight in to the function, to the equation, and see if you get a 0. Now that's going to come out later with the remainder theorem and the factor theorem. That's for later, in another section of the polynomials. Okay, find the zeros of this. Well look, this has already been factored. These weren't factored, these weren't factored, okay. This one here has been factored. Okay, we have x minus 2, x minus 2, x minus 2, which means we have a positive 2 3 times, okay. Positive 2 3 times. This has a multiplicity of 3, an odd multiplicity of 3, okay. Positive 1, so this negative 1, and that's just 1 time, okay, just 1, multiplicity of 1. Okay, so in other words, it's going to cross the x-axis at negative 1, here it is, it's going to cross the x-axis at 2, but it has that slight kink in it, and that's because of the multiplicity. Okay, it doesn't cross it nicely straight through, okay, it's got a little kink to it, notice that. Again, this is just you doing the x-intercepts, the zeros. Okay, let's have a look at another one. Right, this one. Now this one, look at this. Well, for one thing, okay, it's a minus. It's 1, 2, 3, 4. It's going to be an x to the 4th if you were to multiply it out, again, which is why it falls to the left and falls to the right, okay? Right, so this has a positive 1 twice. Multiplicity 2 and even multiplicity, okay? It's also got negative 2 twice, a multiplicity of 2. Now then, okay, so let's have a look down here. As in the previous one, when we had odd multiplicities, okay, it crossed the graph, it crossed the x-intercept, okay? Right, when we have even multiplicities, and it's down here, okay? The zeros have even multiplicities, the graph is tangent to the x-axis. What we actually say is it touches and turns. So it doesn't cross, touches and turns. That's even multiplicity. Look at 1 and negative 2. Okay, so again, get used to that kind of thing. And in fact, the little box is down here. If we have odd and the graph crosses the x-axis, If it's even, then the graph is tangent to the x-axis. It touches and turns. Okay? Even amount of multiplicity, odd amount of multiplicity. The solutions. And finally, right, let's have a look at this one. Now, this one will factor. It's factored by grouping. If you remember this, if you cut this down the middle, okay, what factors out of the first two? An x squared. What's left is an x minus 2. What can you factor out of the next two? Well, a negative 9 will come out. But again, the main thing about this is you just keep the same sign. Can you see they're both divided by 9? Okay, that's why 9 pulls out, and this is the same. All right, it has to be the same. X minus 2, x minus 2. So if you factor x minus 2 out, there it is, you're left with the x squared minus 9. Here it is. And that's the difference of squares, x plus 3, x minus 3. So here we go. We've got a 2, we've got a negative 3, we've got a positive 3 as the zeros, as the x-intercepts. Let's have a look down here. So here we go. Negative 3, 2, and positive 3. And look, if I look, the y-intercept will be positive 18. So that should be somewhere around about here. Okay, so again, zeros of polynomials.